Hi, today we're going to talk about some of the clock sources on the megaAVRs and the importance of selecting the correct clock select fuse settings for the clocks that we have on our hardware. As an introduction, let's look at some of the different clock sources which are available to us on a megaAVR. In the datasheet, System Clock and Clock Options chapter, we can see a flow diagram of the clock sources. On the bottom right, we can see that there's a calibrated RC oscillator, which out of interest is the default clock source which the megaAVR ships with. It also ships with, by default, the clock div 8 fuse programmed, which means that the internal RC oscillator, which is 8 megahertz, with the divide by 8, the processor effectively runs at 1 megahertz. This is chosen because it is a valid clock source for all the different programming modes that the megaAVR supports. Other options here are a low frequency crystal oscillator, a crystal oscillator, and an external clock. So today we're going to look at some of the differences between external clock and a crystal oscillator in terms of the fuse settings and the importance of getting that right. So let's have a look here on the board. We've drawn the situation of what happens when we use an external crystal. So we have a crystal connected between XTEL 1 and 2 pins on our board with two equivalent balancing load capacitors nicely grounded. Internally in the AVR, when we select an external crystal, an inverting amplifier is used, and this is important to actually get the external crystal oscillating. If we, for instance, chose an external clock, we supply a perfectly square 0 to VCC clock source signal into a crystal 1 pin. So let's look at some of the common mistakes which often get made and perhaps why these might get made. In order to do this, we'll connect to a particular AVR board. In this case, we have a Mega 1284 explained, and we will use Studio 6 to connect and program the fuses. So JTAG interface, apply, click to read the device signature, and that ensures that we've got correct connectivity all the way down to the processor, and then click on the fuses tab. Now if we scroll down and we can find the clock select fuse, we can see that right at the top of the list, external clock is, we have some external clock options. So the assumption might be that an external crystal is a type of external clock. Well, so you might make that fuse selection. Unfortunately, this is correct, and you can see all the external clock fuse settings further on in the list. But for instance, if we had to choose that external clock fuse and click program, we would disable this internal inverting amplifier in the AVR, and the external crystal on our board would stop oscillating. Let's have a look at some extra warnings which might be associated with this type of problem as associated to programming. For instance, serial programming. Here we can additionally see that there's a specific statement. Depending on the clock select fuses, a valid clock must be present. And our valid clock source is important even for us to do any type of programming, including programming the fuses. So our AVR now has no heartbeat. How can we revive this somehow? So to look at a potential solution, what we need to do is input a clock source like this, because this is what our AVR is expecting. So how could we generate a signal like that easily? Well, if we had access to a second AVR board, we would be able to make use of another clock feature, and that is the clock output buffer. And there is a CK out fuse, which is, if we look back at the fuse settings, is directly above the clock select fuse. And if we program this fuse, then a clock is output on a CLK out pin. So we could in effect use a second AVR to generate a pulse for the board which we have managed to kill. So let's talk about, as a concluding remarks, also why this is impossible to do on an X-Mega. Well, the difference between the X-Mega is that the default clock source is an internal 2 megahertz RC oscillator, and that the processor always starts up on this 2 megahertz internal RC oscillator, and in order to change the clock source, that is done by software as opposed to fuses, and so the processor actually has to be executing code in order to change the clock source. So this unfortunate situation would never happen on the X-Mega, but if you have happened to make this mistake on a megaAVR, you now know how to fix it.